Hey there, math divas and math dudes. Welcome to the first lesson on congruence and triangle congruence theorems. Go ahead and write this title in your MP notebook. So I'd begin that on a fresh, clean page of your MP notebook. Let's start off by writing the definition of congruent into our notebook. Congruent means that two figures are the same size and the same shape. Let's go ahead and sketch the two triangles that you see below, triangle ABC and triangle XYZ. We're going to go ahead and write a congruence statement about these two triangles. I'm going to just use a mini triangle as an abbreviation for triangle. And I'm going to name that first triangle on the left triangle ABC. Now, we're going to say that is congruent to, and we've got a handy little symbol that looks like an equal sign with a tilde over it, or an equal sign with the similarity symbol over it. We're going to say that is congruent to triangle. Now, we want to name the triangles with the corresponding angles. So, since I started with A, went down to B, and then over to C, I'm going to start with X, down to Y, and over to Z. All right, now, when we name our next pair of congruent figures, you can see down below I'm looking at a pair of congruent hexagons. That's a six-sided figure. And anytime we're looking at figures that have more than three angles, we don't always use that little symbol like we did for the triangle. We will always use it for triangle, but we don't have little mini hexagons that we use to name hexagons. So I'm going to start by naming the hexagon on the left, and I'm going to start with point D here. And I'm just going to go around my figure and say that this is hexagon D, E, F, G, H, I, and that's going to be congruent too. And I want to start in the same position and follow the same order. So we're going to call that second hexagon R, S, T, U, V, W. And there's my congruent statement for those hexagons. All right. Today's lesson primarily focuses on proving triangles congruent using congruence theorems. The first theorem or rule that we're going to take a look at is called the side-side-side congruence theorem. It states that if three sides of one triangle are congruent to three sides of another triangle, then those triangles are congruent to each other. All right, so if we take a closer look at our two triangles, we want to prove that all three sides of the triangles are congruent to the three sides of the other. So I'm going to start by looking at side MK, which is 6 inches long. And if I look at that same left side of the other triangle, side WS is also 6 inches long. So that pair of sides is congruent. All right, let's take a look at another pair of sides. So now I'm going to look at side ME, which I'm highlighting in red here. And its corresponding side on the other triangle is side WC. And both of these sides are 4 inches long, so I know this pair is also congruent. All right, and let's take a look at our last side. On the first triangle, that side is the bottom that I haven't looked at. KE is 9 inches, and its corresponding side on the other triangle, side SC, is also 9 inches. So I know that these triangles have three pairs of congruent sides. So I'm going to write a congruence statement about the triangles. I'm going to say that triangle MKE is congruent to triangle WSC. And I'm going to state how I know, and I know by using the side, side, side rule. Okay, please go ahead and make a sketch of this figure. This is actually, some people might see it like a quadrilateral, a four-sided figure. But the way I'm hoping that you'll see it is that it is two triangles that are connected. And once they're connected, they do form a four-sided figure or a quadrilateral. So we're going to take a look at these two triangles put together and see if we can prove that they're congruent to each other using the side, side, side rule. Now, a lot of times you will see these little slashes through sides of figures, and when you see slashes that are the same, then we know that that's indicating that those sides are the same length. So in this figure, I can see that side AC has a 1 slash mark through it, and so does side DB right here. Okay, so I know that these two sides are equal in length because they both have the single slash mark. All right, now side AB that I'm highlighting in blue right here has a double slash mark or 2 slash marks through it. And so does side DC that I'm highlighting right here. So I know these two sides are equal to each other as well. That pair is congruent. All right, now in order to prove these are congruent using the side, side, side rule, we need to have one more pair of congruent sides. However, we only have one line here. I'm highlighting it in purple, but this line is actually a line in both of our triangles. So it will serve as a congruent side. So we can say that triangle ABC is congruent to triangle, and I want to follow the same pattern. So I started with A and went to B on the double slash mark. Started with the outer angle A and went to B on the double slash. So I'm going to start with D, the outer angle, and go to C along the double slash. And then from A to B I went down to C. I'm doing just the opposite on my right hand triangle, starting with D to C and then up to B. And I know this is true using the side, side, side rule. So yes, these triangles are congruent. All right, let's take a look at the next congruence theorem or rule that we can use to prove that two triangles are congruent. The second one is called the side angle side congruence theorem. It states that if two sides and the included angle of one triangle are congruent to the corresponding two sides and corresponding included angle of the second triangle, then those triangles are congruent. Now I just want to make sure that I clarify what the included angle means. Notice that I've underlined it and typed it in bold because it is important that we really understand what that means. So I'm going to come back and point that out. All right. First, we're going to go in the order. Since this rule is called side angle side, we're going to look at one side, then an angle, then another side. So let's start by highlighting side MN, which I'm noticing is 8 meters long. On my other triangle, side QR, and I'm starting at the top and going down towards the right angle, just like I did on the first triangle, is also 8 meters long. So I know these two sides are congruent. Okay, next, I'm noticing that the bottom, side NP, says that's 14 meters long. I started at N, which is where the right angle is, and went over to P. So I'm going to go to the other figure where the right angle is and go across from R to S, and this side is also 14 meters. So I know the bottom two sides of these two triangles are congruent. Okay, now, as far as the angle goes, the angle that's congruent is going to be this 90-degree angle here is congruent to this 90-degree angle, angle R on the other triangle. Now, let's go back to that included angle. Notice that the congruent angle is in between the two sides. That's what we're talking about when we say the included angle. That congruent angle has to be in the middle of the two congruent sides, which it is. So we're going to say that these triangles are congruent. We're going to write a congruence statement. I'm going to say triangle MNP is congruent to triangle QRS. And I know this by using the side angle side rule. All right, we're going to see if the two triangles that we see here are congruent. Please make a sketch of this figure in your notes, and we're going to look for if we can see two triangles within this large triangle. So what I'm going to do is I'm just going to highlight this triangle here. And then I'm going to take another color and highlight this triangle here. So it'll be very visible that we're looking at two triangles within one. We're going to try to prove those two different triangles are congruent to each other. Okay, the first thing that I'm noticing is that both of these triangles have a right angle, right here and right here. I also see that side PT is 5 feet long, and so is side WT. So I also have a pair of congruent sides. Okay, and last but not least, both of these triangles that are sitting side by side next to each other share a side that I'm highlighting in yellow. So I've got two sides and one angle, and that angle is in between the two congruent sides. So I can say that these triangles, I'm going to say triangle PKT is congruent to triangle WKT. I know this by the side angle side rule. And my proof would be that side PT is congruent to side WT. Oh, not angle. More like side WT. I also know that angle PTK is congruent to angle WTK, since those are both the 90-degree angles. And last but not least, I know that side KT is congruent to side KT. So we know that these two triangles are congruent using the side angle side rule. All right, everybody, I think you've got enough to get you going. Go ahead and do your checkpoint questions, check in with your teacher, and then get your homework. Good luck today, guys.